Welcome back to our discussion of the human sciences. We're now on day 5, a case study in the human sciences, and our case study is the coronavirus. So today we're going to wrap up the human sciences unit, except of course for the assessment. The next class will be devoted to learning how to write the assessment, and then you'll be given a week to do that. Just a reminder, if you haven't turned in the natural science assessment yet, you're falling dangerously far behind. And please understand that if any work is missing at semester's end, you will receive an incomplete rather than a grade. So let's try to stay up to date on these things. All right, so let's quickly review. By the way, it's pretty hot in here, so I've turned on the air conditioning. I hope it doesn't make too much background noise. A brief review. So in order, here's what we've done. We began by examining the scope of the human sciences and found that they look at a wide variety of man-made connections, which makes the human sciences broader in scope than the natural sciences in terms of the relationships they examine, but narrower in the sense that human sciences deal only with human behavior. We then generated a list of knowledge questions, one of which you will choose as the focus of the unit assessment. Next, we talked about methodology, and we distinguished the human sciences from the natural science in several ways. Kameny argued that the human sciences were different from the natural sciences in 3 areas, and here I'm just going to offer a brief summary. He said, in terms of forming hypothesis, human scientists are not just looking at things to learn about them, they're trying to solve problems. So they often anticipate what the data might be, and this invites confirmation bias. Since they're motivated to find a solution, this might affect their judgment. And finally, the human sciences have to use everyday language, and these words have ambiguous meanings, multiple meanings, which might lead to ambiguous results. There's also an issue with deducing consequences that makes it very different from the natural sciences. The number of data points used in human sciences is too large for arithmetic and too small for calculus, so any outlier might unwittingly skew the data. Finally, in terms of verification, human behavior changes very slowly in many cases, so it could not be really tested in the lab. Even in those experiments we can confine to the lab, it's difficult to control every variable in human behavior. And this is because, finally, subjects can always choose to act in unpredictable ways. Today, we want to do a case study, and we're going to look at the features we've studied in action this time. We're going to use the coronavirus as our topic, as of course it's of vital interest to us all. And it's a good example of how we use and depend on the human sciences to understand things such as a pandemic. Now, I realize this may be a very anxiety-producing subject, more so if you have loved ones or friends who might be experiencing this. So if you feel this is too sensitive, you can skip the lesson because you've already learned the basic things about the human sciences. You've learned all the essential features of science, but this is a real-world example that shows how we routinely depend on human sciences for knowledge. So I'm hoping that you're going to follow through with this. Again, let's look at our learning checklist. There are 2 big things I hope you're going to understand at the end of this lesson. First, I hope you're going to be able to explain how and what type of knowledge is creating the human sciences using this Malaysian Institute of Economic Research's coronavirus study as an example. And secondly, I hope you're going to be able to show how this study demonstrates all the features that we've looked at when we examined human sciences. Now, I guess the first question that would crop up is, really, what does coronavirus have to do with the human sciences? After all, isn't that a topic for the natural sciences? Well, understanding the mechanics of the disease and the mechanics of how infection spreads, that's certainly a topic we should leave to the scientific community. It's way above my pay grade. Fortunately, for all of us, the best scientists in the world are working on this. Perhaps this is the greatest number of scientific minds in human history trained on one task. Now, if you're a science person and you'd like to know more about the mathematical prediction models used by the scientists, please follow this link I've included to the Washington Post. It may not open from the Microsoft Word notes, so you may have to copy and paste this link into your browser. So let's get to what we're talking about today. What role, if any, do the human sciences play in the study of this pandemic? Well, first of all, how the information is displayed is of vital importance in making the situation understood. The reading for today, Mapping the Coronavirus, comes to us courtesy of our resident geography guru, Mr. Moorhead. And the article shows that geography as a human science plays a key role in understanding the pandemic. How the information is presented is a crucial step in combating a disease, and this requires a thorough understanding of maps, that is, of the geography of pandemics. If you've not already read Mapping the Coronavirus Responsibly, first, please wrap yourself on the knuckles because you're not doing your job. But go ahead, read it. Please pause this while you read it. If you have read it, or when you have read it, I want you to open the guided learning sheet and answer the first 5 questions under Mapping the Coronavirus Responsibly. I'm going to pause for a moment. So don't go forward in this screencast until you've attempted your answers to these 5 questions. And now I'm going to go over my answers. And again, there'll be also a soft copy of this will go online at 4 o'clock this afternoon. Why is a choropath thematic map of red color and based on the total number of cases rather than on rates per 100,000 misleading? Well, my answer is the color of red is a questionable choice because it's alarmist in an already troubling situation, and it invokes emotion as a way of knowing, possibly overriding rational analysis. As to the other part of the question, the total number of cases does not take into account how many people in each area could possibly have been infected. So the absolute number of cases in large versus small cities does not tell us how it affects the population. This leads to question number 2. Why is the classification scheme in levels of 1,000 or increments of 1,000 also misleading? Well, the problem is in most cases, there are substantially fewer than 1,000. And when you use that number as the cutoff, Wuhan appears the same color as 3 other cities that have substantially fewer cases. So given the relative small numbers in most areas, it would be better if there were a finer gradation of numbers was used in this table. Question number 3, what's the advantage of using a bar graph? Well, because of the problems mentioned in question number 2, a bar graph gives us a much better representation of the differences between cities. As we see areas lumped under the same color in the choropath map, in fact, have far fewer cases than Wuhan. So by putting a bar graph, you get an absolute idea of the numbers and you see how they stand relative to one another. We could also have used a dot density map. And the advantage of this is the dot density maps use totals rather than rates because the technique itself automatically renders the data as visual density of the dots of the same size. That aids in comparison. The only drawback to the dot density map is that each dot is going to represent, a certain number of cases, 10 cases, 10,000 cases, and you can't mistake it for one. But both graphs and dot density would probably be better than the choropath method that was introduced in this article. So please generate a knowledge question, okay? Don't steal mine, do your own work. But mine was, to what extent is knowledge shaped by the methods one uses? See, that's a broad question, could be applied to anything in the human sciences, but looking at the presentation, it could be a question we've extracted from this real life situation. All right, so now we'll leave the study sheet for a moment, and I'm back on the summary of what we've learned so far. So first of all, we have learned that, we rely on accurate geographical depiction of the pandemic to form a reasonable understanding of the risk it presents. So we already see how geography as a human science figures into understanding of pandemic. But now we get to a bigger issue. Next, as the information from scientific studies is made public, people will react to this information. How they react, the effect and the consequences this has on predictions is a human science issue. So now we're going to enter the second part of our coronavirus case study. And let's begin with an overview. Again, our study has two aims. First, the part we're going to do right now is to show you how we, in fact, do rely upon the human sciences, and they do provide us with useful and accurate knowledge. After that, the second part, we're going to tie in more to the TOK part, the methodology part. We want to learn how, at the same time, this case study highlights the issues and features that we've discussed throughout the unit. That is, how, despite some of the limitations we've noted in the human sciences do succeed in producing useful knowledge. Now, there are about 10 questions and there are sub-questions on this. So you may do it on your own. I know some of you like to do that. But if you want to get two, or you might even want to get a group of up to 4 people, share different parts of this study sheet, put it all in a common document, and ideally talk to each other before you put it down so you get more perspective. So if you're doing a group, you make a shared document, you can gain more perspectives. As always, you can check your answer. Well, we're going to check our answers right away, and then you'll get a soft copy of it later today. Now, the big thing here is, I don't know how technical you're going to find this. I tried to make it clear, but I'm never sure. But it's important that you try to write all the answers. It doesn't matter if you get them right, because if you try to write all the answers, then when you read the other responses, you'll better be able to understand how to correct the responses. So let's get started. For the rest of the screencast, you'll continue with your guided learning sheet, and you're going to open this document from the Malaysian Institute of Economic Research called the Economic Impacts of COVID-19. Both are on Google Classroom. Now, the purpose of this part of the study sheet will be to show you how we are, right at this very moment, using human science methodology, predict, explain, and we hope rectify the threat from the coronavirus. And this will demonstrate how human sciences are a key element in this. And then in the second part, we'll use the same sources, and we're going to look at how the projection on this document mirrors the nature of human science methodology we've been studying. And then, of course, before we do, you want to check your answers against the checklist. But let's go back now. What I would like you to do now is pause, and I would like you to answer questions 6 and 7 on the guided learning sheet. Don't resume the screencast until you've done that. Okay, we're back, and we're going to orally review questions 6 and 7. Remember, the purpose of this section is to examine the type of knowledge produced in the human studies using this as an example. So the first part of this deals with the charts on page 2. Again, like any science model, human science model, it seeks to describe, explain, and predict the outcomes. Ooh, now it's starting to rain. I bet you can hear that. All right. The first question. What does the data in the first graph show? Well, the first graph shows the rate of infection up to the day of the report. It represents a trend, and in this case, an alarming trend, as the number of cases is rapidly increasing. It also represents the data from which the rest of the projections are going to be based. Now we go to figure 1, the second graph, the graph at the bottom, and looking at these sub-questions. The first one is looking at the graph at the top left. what prediction does it make about the trend if the MCO is put in place? Well, the answer is it predicts that if an MCO is put in place immediately, the upward trend will level off in about 2 weeks, reversing the earlier trends, and predicts the pandemic will largely be over by May 20th. The next question says, look at the chart below with the double yellow boxes. What does it predict? Well, it extends the prediction. It predicts that extending the MCO will reduce the total number of cases and will end the pandemic sooner. Sub-question 3, looking at the boxes on the right side of the graphs, what is the prediction about the adequacy of beds and intensive care unit beds if the MCO was followed? Well, the answer is, the projection is if we follow this order, there'll be an adequate number of both sets of beds to deal with those affected by the virus. Finally, what recommendations does the report make based on its prediction? Well, it says that we should probably extend the MC order for 2 more weeks as it will end the pandemic earlier. Now, the second part of case study 1 is on page 4, which applies the results of the virus's projected behavior with the MCO in place to the economic health of Malaysia. So 7A, the question 7A, what does the graph on page 4 show? Well, the answer is it shows to what degree the pandemic will affect Malaysia's GNP. And then I ask you to list one macroeconomic impact and one recommendation from each. So I'm going to read all of them. Any one of these would be fine. The macroeconomic impact, well, it looks like the GDP is going to go down by 6.9%. It looks like we'll have a negative 2.9% growth rate. It looks like 2.4 million out of 16 million will lose their jobs, 1.6 million unskilled, and 780 skilled workers. So again, it's going to fall most heavily on unskilled workers who also get the lower wages. And it makes a number of recommendations. It orders that make people comply with the MCO. It argues you should inject an initial 75 billion into the economy above the initial 20 billion stimulus. And it argues to get some of that revenue back, they should bring back the GST. Okay, so that concludes the first part of the case study. I hope what it showed you is that human sciences are being used right now to understand, predict, and form a plan of action in respect to the pandemic. Now, in the second part of this, we're going to look at what do we learn about the human sciences from this case study. Again, you're going to be using the economic impacts of COVID-19 handout again, and you're going to write your responses in the guided learning sheet. The purpose of this exercise is to show you how this projection mirrors the nature of human science methodology we've studied in the year. So now we're going to go over orally the answers to questions 8 to 11. So 8 was kind of asking you to apply what we've learned from Kameni to this situation. So we start with hypothesis formation. The question is, to what extent is there a motivational aspect to the study, and how might this affect the outcome? And the answer is, since the human scientists here, the economists, are trying to solve a huge economic issue, there may be a tendency to seize upon solutions that offer the most hopeful outcome. The projections might be optimistic, driven by an urge to ease people's fears. Deducing consequences. What is the data range in the study, and why might mathematical calculations be prone to error? Well, the data in this range is too large for arithmetic calculations and too small for calculus. Therefore, any outliers might unduly influence the results, the predictions, and the verification. On verification, how will we verify the predictions? Well, this is the really tricky part of the human sciences. We will find out about our predictions only when the time has passed. Now, if it's successful, which we hope it is, that's great. But if predictions are wrong, chances are the time to correct any issues has long since passed. This is very different from human sciences, where you run an experiment. If it doesn't work, you just run it again. This is a one-shot deal. The next question in here was to take a look at the G model assumption, the assumptions on which this model is based, on page 3 of the handout. And you're supposed to examine both the best and worst case scenarios. So question A is, what does the difference between the best and worst case scenarios tell you about the nature of the predictive law or methods being used here? In other words, they're offering a law in the human sciences here. And the answer is, like most human science laws, it is predicting a general trend based on current conditions that is statistically projecting an outcome. That's about as clear as I think a human science law can really get. Now, coming to question B, following up on this observation, we learned that human science laws are not based on more basic covering laws, as in the natural sciences, but are based on individual and unique actions. How is this borne out in the model? And of course, the answer is the model is not based on simpler indicators of the biology of disease, but rather on the individual choices of each citizen. So we're trying to predict what each citizen is going to do, but each citizen is going to make up their own mind, i.e. whether they choose to obey the MCO order or not. So question 10, we have studied both the quantitative and qualitative methods in the human sciences. So question A is, in what sense is this a quantitative study? And the answer is, as an economic study, it is more of the quantitative approach, as it measures empirical data and projects it into the future. And in predicting the so-called flattening of the curve due to the MCO, it is employing the quantitative assumption of rational choice. It is rational and in everyone's self-interest to self-quarantine. However, that does not mean they will, but the projections depend on this behavior. Leaves us to question B. Is there any sense in which there is a qualitative aspect to this study? We have previously seen that there's always an interpretive, Verstehen aspect to even qualitative studies and a quantitative aspect to even qualitative studies. In this case, the dependability of the quantitative data rests on the understanding that people must obey the MCO directive. If this does not happen, any adjustments will require a meaning-based, or that is a Verstehen understanding of why people defy the order, for example, fear of being away from their family, so on and so forth, and how to correct it. So even in this basically quantifying approach, there is a qualitative aspect. We have to understand how and why people are behaving the way they do. And finally, to wrap up this discussion and case study, to what degree do we have certainty in this example of a human science prediction? Well, we have confidence that if we follow the prescriptions that is made, and if our data is accurate, we can reduce the worst effects of this pandemic. Further, we can also predict what the alternative is, what will happen if we do not. So now, again, the purpose of this exercise was to show you how this projection mirrors the nature of the human science methodology we've studied. Before leaving the section and the screencast, let's check our understanding against the checklist at the top. Okay, so I hope you are now able to explain how and what type of knowledge is created in the human sciences using the Malaysian Institute of Economic Research coronavirus study as an example. And second, you'll be able to explain how this case study highlights the unique elements of the human science approach to understanding. In our conclusion, you are in fact living through a time period that has put extraordinary demands on both the natural science and the human sciences to explain and control the pandemic. You can understand how much is at stake and how much we depend on the human sciences to help us explain our current situation as well as offer a way out of this plight. I hope you will appreciate how, despite the complicated nature of human interactions, the human sciences are indispensable to our daily lives. Well, that wraps up our the learning portion of the human sciences. Next class, we will have an in-class workshop on how to prepare for the human sciences assessment. Until then, be safe.